I'd tell you a joke about UDP, but you might not get it. Now that's funny, but the problem with nerd jokes is only our friends would get it, and we don't usually have any. By the time we're done here, we will examine UDP communication and compare that to TCP. I just finished creating 3 complete videos explaining, I would say, the foundations of TCP communication, from the session start to maintaining it with windowing and increasing and shrinking, decreasing window sizes, to the way sessions end and communication gets pushed up to the application. I mean, and I could just go on and on. I could probably create 10 more videos just explaining TCP in depth. Then I came to UDP and I sat there and I was like, so yeah. There's really not that much to it. I could contain it all pretty much on this one slide because it is designed as a send it and forget it protocol. I could say it's the brother of TCP, but it would be like the evil twin brother. You know, that's like TCP is the noble one and UDP is completely the opposite. TCP sets up a full-on session and sets up sequence numbers to ensure that all the packets get there, and acknowledgement numbers to that allows the other side to communicate back and say, yes, I got it, please send me more. UDP, exactly the opposite. There's no sequencing, as in no way of putting it back in order. There's no acknowledgements, no way to ensure that it was received by the other side. There's really no anything beyond port numbers and a little checksum in the header to make sure the data didn't get corrupted. So you might go, well, who would even want to use this protocol? And the answer is a lot of things. First point is it's not who would want to use this protocol, as in you and I don't really choose which protocol we use. It's the applications, and the applications that need either stimulus response sort of communication, like DNS, where there's stimulus, I need to look up this domain name, and only a single response back saying, here's your lookup. There's no sense in setting up a full-on session that says, okay, let's start the ACK, okay, let's confirm our, like, that's way too much overhead for just a quick stimulus response. But whoever creates DNS or builds DNS into their application, like Windows, like Mac OS, has to also include a reliability mechanism. Instead of just saying, okay, just send the data and allow TCP to make sure it gets there, they actually have to code into their application. When I send this DNS request, if I don't hear back in 2 seconds, 1 second, half a second, however long they want to put in there, then send that stimulus again because maybe it got dropped. There's no acknowledgement to ensure that it didn't, so the application developer has to program that in. The other kind of application that works well with UDP, that real lightweight, hope it gets there sort of thing, is any real-time streaming. So what I'm doing to you right now, talking over video, the words going into my mouth are going into this microphone. My face is on your screen. It's real time. If there's a packet that gets dropped along the way, I don't want to resend it at a later time because that time has passed. There's no use in putting that pixel back in place later because it's no longer relevant. So online gaming, streaming video, streaming movies. I'm looking at my TV right over here. Voice over IP, where you've got phone calls that are happening. All of that uses UDP, but often we'll have TCP set it up. So let's do this. Just like I did with TCP, I want to bring up Wireshark and do a capture of a UDP session. So first off, I'll bring it right into the screen and just literally turn it on. Double click it right there. Let it start going to town, capturing some data. Okay, so just yesterday, you can see 20 hours ago, after I recorded all the TCP stuff, I had the thought, I was like, I should create a YouTube video that just explains to people how to use Wireshark or how I use Wireshark, because that's what prevents most people from getting into it, is just that initial barrier. And once you get people past that and go, oh, it's not too bad, there's like a whole world that opens up. So I posted this on YouTube, and YouTube uses real-time streaming, meaning it's going to stream this video. Now, you can see that YouTube pre-caches data right here. So if I were to click ahead a little bit, you can see it. Oh, it's starting to play. You can see that it loads a little bit more data. That's how it does it, and still keep bandwidth efficiencies at the same time. Let's scoot this down a little bit. The frame of not not too far to where I can't get my scroll bar anymore. The frame of YouTube, meaning the shell of it, the thing that holds this video player, is all TCP based. The controls are TCP based, so it knows that it was received when I click that button, right? So I'm gonna click on this button. Watch Wireshark behind the scene. Oh, hang on, not play. Let's pre-cache some more data. I'll click ahead so it loads. All of a sudden we see, oh, we see a whole bunch of TCP. Hang on, what's up with that? TCP. Wait a second, what's going on? Why is it loading everything with TCP? Well, this is interesting. Maybe. No, come on, YouTube. Hang on. Let's stop this capture for just a second. I'm gonna stop the capture. I'm gonna put on a display filter of UDP. Enter. And okay, so this is just stuff roaming around my network. These are some early packets. We'll look at those in a second. DNS. Wow. Look at that. YouTube shocked me. It went TCP on me. Now this is crazy because I did this just a little bit ago. Hang on. Let's go to a different video. Hang on, let's start the capture again. I'm wondering if just because I paused or something, it like flipped over to TCP. So that's something interesting I didn't even know that YouTube even could use TCP for its video streaming. Okay, so let's go to this one right here and just see if it stays TCP. Look at that. It's just shooting streams of TCP across the screen as I'm pre-caching that information. Okay, hang on. I'm curious. I'm going to close the web browser completely. Open it back up. I'm over on Bing, and let's go to what's another video streaming service? Video streaming service. Let's see. Hulu. Vimeo. That's one. Let's go Vimeo. All right, so I'm seeing TCP going on behind the scenes, and it looks like we got a little guy standing on a mountain. Let's click on him. Let's watch a Vimeo video. Looks like I got to scroll to the bottom here. Click on this guy. Let's see if I get the actual video loader. Okay, so wow, look at that. It's all going TCP based on me. That's interesting. I had this whole demo lined up thinking this is going to be UDP all the way, but it looks like a lot of these video streaming. Hang on, let's do this. I'm going to throw a display filter on there of UDP. Enter, and it shows me just the UDP packets coming in. And it looks like let's examine a few of these. All right, so we've got some notify messages, SDP. That's the simple service discovery protocol. There we go. Scroll down a little bit. Hang on, let's stop the capture. We've got a lot of packets coming in, but it looks like none of them are the video stream itself. That's interesting. So do this for me, because I've done this before. I've actually gone out and captured video streams, and it's just UDP all the way. I must have done something. I don't know what I did. Maybe I'm using Firefox, and Firefox is different. I don't know. But it's using TCP. Do a capture of your own and see if you can get some UDP. Regardless, I'm just kind of in this like wow discovery mode. Let's get back to the topic at hand. I want to show you some UDP traffic right here. So let's grab this. So you can see right here I've got MDNS. What is that? That is multicast DNS service. Apple is huge on using this. It allows them to announce their services within a network, and all the devices can see it. That's why one of the reasons Apple is so plug and play is because they flood the network with all kinds of traffic. They're designed for home, small office sort of networks. And I'm not dogging on Apple by any means. You can tune it to where it's more enterprise ready, but you'll just see their devices broadcasting all the time. Look at this. I've got my living room Apple TV sending out queries, and all it's doing is just broadcasting, announcing its services out there. You can see I've got a Marantz. That's my AV receiver that is connected to the speakers and all that kind of stuff. So all of these MDNS is simply announcements of all these different services to my network. That's UDP based. Now look at this. Here's what I want to show you. UDP, if I expand this again, layers of the OSI model, layer 1-ish, 2, 3, 4, there's UDP. This is all UDP provides. Source port, destination port, length of the packet, and checksum, saying this is the little hash at the end to ensure that the header doesn't get scrambled as it goes by a fluorescent light or something like that. That's it. That's all there is to UDP. MDNS is the application stacked on top of UDP. So if they want any additional functionality beyond the source, the destination port information, they have to design that into multicast DNS. Let's scroll down a little bit more. You can see we've got some simple service description. Again, all kinds of different services use UDP, but if you look, UDP itself doesn't change. It's just a simple source, destination port, and checksum that's in the header. So I could keep going down, finding all kinds of different traffic type that uses UDP, and most of it's going to be that stimulus response or just notification sort of message. But the UDP piece of it is simply port numbers. That's all there is to it. You've now seen UDP communication and compared that to TCP. I hope this has been informative for you, and I'd like to thank you for viewing.